let's talk about compound inequalities. These are inequalities that contain two inequality signs. So let's look at an example. If we have -8 is less than or equal to 2x plus 5 over 3, which is less than 4. This is our compound inequality because we have two inequality signs. So the way I like to work it is to solve it all together as one problem. Our goal is we want to get x in the middle and numbers on either side. So that's our goal. So I like to look at it as three different sides. We're trying to get x by itself, so whatever we do to the middle, we just need to also do that to each side. So to start this problem, I want to get rid of the 3 in the denominator first, so I can multiply each side, or all three sides, by 3. So we have, let's see, 3 times -8, 3 times 2x plus 5 over 3, and 3 times 4. Okay, the reason we do that is now if you look in the middle part, our 3's cross out, and we no longer have a fraction. So that leaves us with -24 less than or equal to 2x plus 5 less than 12. Okay, so from here we're still trying to get x by itself. So our next step would be to get rid of that 5 in the middle, and we can do that by subtracting it. But we have to subtract from all three parts. That gives me -29. 2x is by itself in the middle, and 7 on the right. We're almost done. Our last step is we need to divide out by 2. Since we're dividing by a positive, we don't have to worry about changing directions of the sign. So that gives us -29 over 2 less than or equal to x less than 7/2. So we've solved it. So now we want to write our answer in interval notation. So I like to start, before we write it in interval notation, I like to draw it on a number line. That always seems to help transferring it into notation. So if we mark it on the number line, we have -29/2 over here and 7/2. Okay, and so what this says is x is anything greater than or equal to, but less than, in between -29/2 and 7/2. So we're almost there. We do need to decide and look more carefully at what happens at the actual endpoints at -29/2 and at 7/2. So we see that in this problem, x is greater than or equal to -29/2. So what we can do is we can draw a closed dot, and this just represents the fact that -29/2 is part of the solution, the actual point. But if you look over at 7/2, x is less than but not equal to. So we can denote that as an open dot, which tells us that it gets really, really close to 7/2 but not equal to 7/2. So this is how you would draw it on a number line. In interval notation, we just write the end points. So you always write from least to greatest, or left to right. So we would write this as -29/2 is our lower boundary, and 7/2 is our upper boundary. And the key thing to do in interval notation is to know whether you put brackets or parentheses. So if you have a less than or equal to, which that means you have a closed dot, that's the same thing as a bracket. They all mean the same thing. So a bracket means that -29/2 is included in the solution. And over here at 7/2, since it's not equal to, we have an open dot, which is the same as a parenthesis. So this is our answer. So here we have another example. It's another compound inequality. And remember, our goal in working the problem is to get x by itself in the middle part. So let's just start working it. My first step is I want to get rid of the parenthesis. So in the middle part, let's distribute that negative through. Distributing the negative throughout the parenthesis, we get negative x and minus 5. And we can combine negative 6 and negative 5. So that gives me negative 11 minus x. Okay, so we want to get x by itself, so we have that negative 11. So to get rid of that, we can add it to, remember, all three sides. So we would add it to the left, and to the right, and to the middle. So 0 plus 11 is 11. Here, this disappears and just leaves you with negative x. And 3 plus 11 is 14. Okay, it seems like we're done, but we have one more thing to do. We have negative x, and we want positive x. So that's like an understood 1, or negative 1. So we can divide out by negative. Now remember, with inequalities, if you multiply or divide by a negative number, you have to change the directions of the signs. So this would give us negative 11. That sign changes directions to greater than. We have x in the middle, and this sign changes also, greater than or equal to negative 14. You can just bring the equal sign with the sign, just change the direction. So this is our answer. Now we want to put the answer into interval notation. This is the way we want to write it. So this is a perfect example of why it really helps to draw it out first, because the way that the answer ended up, it's written backwards than what you would think. So be careful with that, because it's very important in interval notation. It has to go from least to greatest, from left to right. So if you notice, negative 14 is actually smaller than negative 11. And this says that x is less than negative 11, but not equal to, so we can draw an open dot. But it's greater than negative 14, but also equal to. So we draw a closed dot. Okay, so that's how we would draw it out. Once we have it written this way, or drawn this way, it's easy to do interval notation. We always write from least to greatest. So we would have negative 14 as our lower bound, negative 11 is our upper bound, and since we had a closed dot at negative 14, that's the same as a bracket. And then an open dot at negative 11 is the same as a parenthesis. This is our answer.